All right, welcome back from spring break. It's a beautiful day for iPhone applications. So today has absolutely nothing to do with Angry Birds. I just thought that starting with that would make today seem much more fun. But it is about iOS and about continuing last week's conversation about introducing this coming month's project, which will be your first of 2 iOS-based applications. I'll try, since it's been a couple of weeks, for some, a couple more weeks, I'll try to pepper the group here with some questions so that we can all get back onto the same page as to what some of the concepts are that we've been exploring, as well as what some of the new ideas for today and onward are. So without further ado, we're back in this MVC world. And MVC stands, of course, for Model View Controller, but in English, in a sentence or so, what does that actually mean? Okay. +1 for me. Carl.
So MVC is like this paradigm where you can separate out the logic for what you see and your business logic for controlling stuff and your data.
Okay, good. So it's this paradigm for designing software in such a way that you separate your views, your controllers, and your models, which are defined respectively as the aesthetics, are the views, the models are your databases or just your data sets. Even though we used MySQL or the like for previous projects, realize that model can really model anything. It can be an XML file, it can be a CSV file, it can just be some generic data that's hard-coded, but it provides the abstraction that your data is coming from this real-world entity or this representation of some data source. And then finally, the controller is sort of the brains behind the whole operation that talks to the models to get some data and then pushes that same data or some transformation thereof to the view. So he's kind of the middleman. And generally, you should not cross these boundaries. So this is taken from Apple's own documentation, and you'll see different depictions of MVC on the internet depending on the language and the context. And sometimes you will see lines connecting view to model, but generally that's a bad thing. Generally, all communications should be routed through the more intelligent arbiter known as the controller. So if you're writing code, henceforth, especially in iOS, where you have a view that's talking directly to a model or vice versa, that's probably not the best design. Rather, the controller should be asking for data from the model and then passing it into the view, as this topology here suggests. So try to keep that in mind, and we'll try to provide feedback if we see otherwise during weekly, every few weeks design reviews. So where did we leave off? So we started last week playing with some actual iOS code, and you launch Xcode. This here is version 4.3.1. The Project 2 specification will make crystal clear exactly what software you should have on your computer so that you don't accidentally start using some old version, your code doesn't work and the like, so do read that carefully. But here are the templates with which we can begin. So just sanity check. What are these templates exactly? What are these various types of applications you can apparently create? What is it we're choosing here? Zach.
Different slates that give you different framework or not framework, but kind of template code.
Okay. Yeah, so it's just essentially default sample code that you can start with. They're not so much clean slate since they do actually have code in them, but it essentially means that Apple started with the most minimalist template, which is generally considered empty application, or even something more minimal than that, and just packaged up some code, some nib files, the UI mechanisms, that collectively might help you get started writing more interesting apps more quickly. So today, we'll start off with the single view application. And this one's interesting because it actually does give us that MVC framework right out of the box. So if I go ahead and click on this, I can choose, as last time, a product name like demo. Company identifier should just be most anything unique, so flipping around someone's domain name that you own is typically standard practice. We can leave class prefix blank. We'll use iPhone just because it tends to fit on the screen and the projector a little bit better. Storyboards we'll wave our hands at for now, but the second box, use automatic reference counting, absolutely check this. This is this new fancy feature of the latest version of iOS that Apple introduced last summer, and it will make your lives easier. If you struggled with things like malloc and free in a C-based course, realize that these details are now largely hidden from you, at least the free side of things, but in a week or two we'll peel back this layer and talk about what's actually happening, since this notion of automatic reference counting is used in other languages that you yourself might have used. And unit tests we'll start checking, but we'll talk about those in a week or two. Unit tests are classes that you can implement that test other classes that you wrote, so that if you make some change or your partner makes some change, you have some mechanism already written by you to make sure that he or she didn't just break your entire project because he or she introduced some bug that causes one of your own tests to fail. So I'll go ahead and click next. I'm going to go ahead for now and just save it wherever. On my desktop is fine. And voila, we have this nice little confusing interface here. So the only thing that's important for now is to take away from this very simple template the flow of what code is talking to what, so that when you guys sit down to dive into project 2, you actually have a sense of what you should change, where you should begin, and so forth. So let's just expand some of these folders real fast. And there's a whole lot of stuff here, but recall 2 weeks ago we essentially said ignore many of these, or at least most of these. But a quick tour back through this. Let's see if we can slide over. Projector's not quite cooperating. There we go. Let's start up here. Main.m. When in doubt, start with the file that's at least most familiar. So what kind of code should you be writing in main.m? Okay, good. So none, right? So for the most part, this is the function. Now main is in main.m, kickstarts the whole process. And to whom does main effectively hand off control of an iOS app? So an app delegate, which is sort of a generic term describing the notion of a guy who's in charge of an application. So it's it's a class to whom you delegate control. And where is this coming from? Well, it's a little cryptic here, but syntactically. But argc and argv are familiar. We can ignore nil, which is essentially like null for now. But this fourth argument to UI application main is essentially informing this class, this function that's called UI application main, to whom control should now be handed off. What file should now take over this application? So app delegate is actually the name of a class. The keyword class is a message that we're passing into that class, which is to say that class, C-L-A-S-S here, is a class method or an instance method. So it's a class method. Why do we know it's a class method? And apologies for the confusion of the names here, that we're talking about a class that's also a class method. Why do you know it's a class method? Exactly. There's no instance. We didn't call alloc, which means we didn't allocate a class, which means we must be passing a message to just the class name itself. So alloc is a class method. Class happens to be a class method, and you can perhaps guess, what does it return? So it returns a representation of that class that you can then pass to another function, NSString from class, which is going to convert app delegate to quote unquote app delegate. Now, why the heck did we just jump through all these hoops when we could have just hard coded quote unquote app delegate? It's a little more generic way of doing this. So for now, though, you can ignore what's going on in main.m, because all that matters is that control has now been passed off to appdelegate.hn.m. Yeah?
Why is the function called here in sort of the C form for rather than Objective-C?
So Objective-C is a proper superset of C, which means it still starts off in procedural style using a traditional main method. The OO layer was added on top of C. Good question. All right, so let's turn our attention now to appdelegate.h. So when in doubt as to what's going on with something, generally I would start with the .h file before diving into the .m file. But let's see what's now in this file. So all of this is boilerplate code that we were given. So what's interesting here? Well, what does uikit.h refer to? What's likely inside of that file? Yeah, so declarations, so C-style declarations of things like UI button, UI view, UI slider, UI ... a whole bunch of UI mechanisms that we started to see 2 weeks ago in the WYSIWYG editor that let us drag and drop things like buttons. All right, let's skip the second line for now. At interface app delegate, UI responder, and so forth. Someone want to translate that one line into slightly less technical English? What is that line doing? Yeah. Okay, UI, close. Flip your story around a little bit.
UI application delegate will implement all the features.
Flip the other possible way.
All right, never mind.
Okay. Someone want to tweak? You're on the right track. Just got the order reversed. Yeah.
So
Yellow.
app delegate implements the features in UI application delegate.
Good. Okay, so app delegate is the class we are declaring in this file. It descends from UI responder, which is apparently some class that Apple wrote that presumably has something to do with responding to UI stuff, touches and drags and presses and so forth. And the angled brackets there denotes a protocol, aka interface in PHP or Java, and this has declared in it some methods, foobar and baz, and the fact that there is this angled bracket notation here says that this class, appdelegate, that we are implementing promises to implement the methods that are declared in that protocol. aka interface. So essentially read it left to right. I'm declaring this, it descends from this, and also I will implement these additional methods that are presumably not in the parent class. That's why I'm specifying them as a protocol. All right, any questions? Well, let's close the declaration. At end just means end of that. So now let's look inside of the class. These two things. So what is a property in Objective-C? What's a property? And what's its relationship, say, with an instance variable?